Anytime you want to use electricity, it has to be available around where you are. Before electricity can reach your house, it needs to be transported. And the same holds for the use of gas. Therefore, there has to be an energy infrastructure to transport energy from one place to the other. The learning objectives for today are to recognize how energy is transported through our system and to understand the components of the electricity and gas infrastructure. So, we will focus now on the transportation of energy and what is needed to make this happen. Let's start with electricity. On the slide you see a simplified energy chain for electricity. The consumers are on the right, and on the left there is a power generator. How do we get the electricity generated in a large-scale power plant to reach the consumers? Well, there is the electricity grid. The electricity grid typically consists of several levels. These levels are distinguished by their voltage. There is the high voltage transmission grid and we have a low voltage distribution grid. Let's take a closer look at these. In this slide we focus on the transmission network. The transmission network serves to move generated electricity over long distances to the areas of demand. This is the main function of transmission networks, to connect centers of generation to centers of load. Sometimes generation is far away from where consumption is, and then we need to transport electricity over a long distance. The point is that when transporting electricity, some of the electricity is lost in the form of heat. If we increase the voltage level of the power line and transport the electricity at a higher voltage level, the losses will be reduced. In practice, long-distance transport takes place at high voltages above 50 kV and up to 1000 kV. This equals 1 million volt. Typically, electricity is transported by the means of alternating current overhead lines. But sometimes, for example, for crossing a sea or for connecting systems with a different system frequency, we use high voltage direct current cables. The transmission grid is managed by a transmission system operator. The transmission system operator is responsible for the transport of electricity in a large area. When the electricity reaches the area where consumers are located, the final transportation step takes place through the distribution grid. This is the local electricity grid that runs to your house or to your office building. The distribution grid consists of underground or overhead cables of a lower voltage level. The distribution grid runs to all the buildings which require electricity. It starts at the connection point with the transmission grid. Here, the transformers are located which transform the electricity from a high voltage to a lower voltage. And from there, the electricity is sent through the distribution grid in order to reach the consumers. In this slide, we have added the necessary transformation steps. Transport of electricity through the electricity grid takes place at different voltage levels. For the transmission grid, we use high voltage. Step-up transformers increase the voltage of the generated electricity to high voltage. So transformers are located between the generator and the transmission grid. As said before, transformers change the voltage level of electricity. At a higher voltage, you need less electricity flow to transport a certain amount of energy. Because there is more energy content in electricity at a high voltage level, we can compare this with a road. To transport a certain amount of people, we can use small cars, but then we need a lot of vehicles. But if we increase the size of the vehicle to a bus, we can put more people in one vehicle. And now we need fewer buses for transporting the same amount of people. This also happens in electricity transport. If we increase the unit size, which is the voltage level, then the flow rate, the current, the number of buses can be reduced. When the high voltage transmission line reaches the region where the electricity is needed, the voltage level is again reduced. This is done by a step-down transformer. Typically, there are different sizes of consumers. Each consumer is connected at an appropriate voltage level. Large-scale consumers are connected to a higher voltage level of, say, between 6 and 20 kilovolt. Power is also fed into the distribution grid at this voltage level. But before it reaches your house, there is an additional transformation step to further reduce the voltage level. Typically, in Europe, the regular voltage level in houses is 240 volts for households. And for 3-phase current of business customers, it is 380 volts. This slide represents the gas chain. It consists of 3 phases: production and processing, then transport and storage, and finally distribution. Gas is being produced in a well. By drilling a hole above a gas field and placing a production platform above it, we harvest the gas from the ground. This can be done onshore or offshore. The gas needs to be processed in order to clean it and to make it suitable for transportation. Transportation is done through the transport system. The gas transport system consists of high-pressure pipelines running through Europe. It allows the transport of gas over long distances. The high pressure is needed in order to have a high flow of gas. This pressure is achieved by means of compression. Gas compression is done in a compressor station. If there is excess production, gas can also be temporarily stored in storage tanks or underground fields. Or it can be converted into LNG, liquid natural gas, by cooling it. Then it can be stored in tanks. Finally, we come to the gas distribution grid. Here, gas is transported at a reduced pressure. A decompressor is used to reduce the gas pressure to a level on which it can be supplied to the consumer, to you. The electricity infrastructure and the gas infrastructure need operators. Basically, there are 2 functions: a transport function and a system balancing function. A transmission operator is responsible for the transport of gas or power through the electricity grid or the gas network. A system operator is responsible for the stability of the system. In Europe, these 2 roles are often integrated into the role of a transmission system operator, abbreviated as TSO. A single TSO for electricity is responsible for the operation of the transport grid and the transport of electricity in a certain geographical region. And a single TSO is responsible for the gas grid in a certain geographical region.